Okay, hello everybody. We have the Enceladus here, if I unmuted her.
Hi everyone.
Yes, okay, she's laughing. We're all here. I'm a silly guy, and I gotta be a little less silly because we got some sorting to do tonight. And sorting, there's nothing silly about sorting, but there's something very silly about comparison key sorting that we're going to be doing. But
I will find a way to make sorting silly.
Oh, we're going to make it silly. No chunking it though. No going for the easy.
There will be variable names, I assure you.
Oh man. All right. So that's what we got in store for you. I am sorry about last week. We had a major tornado. Most people in Connecticut lost power. Including yours truly, and it was a lot of fun. But we're back, and some of the settings are a little rough, so bear with me, please. As usual, let us know if the audio levels are no good or something isn't showing up right in your stream. Just ping us in the chat. It's great to see all of you. And one little item before I forget, and we can talk about it totally at the end if we want, is that we have emotes. That's right. We have our first set of emotes, which of course are still pending approval. But more importantly, we have some sub badges. So NC, who can type a message if she will, can show off one of our emotes there. There's the Tau is better than pi. Sorry, badge. I keep saying emotes. I'm going to be stuck on that all night. But that is some badging. So we're turning into a real stream, right? This serious. We had to get all the way through a C course to finally do that, but hey, here we are. So what do we have to do tonight? We have, let's see, we have some learn stuff. We have Jessie here, hopefully on your displays, and she's got her cool badge. And let's see, we've got some topics. So we're here in topic. I did a little quick subdivision of topic 11, and I broke out hashes from sorts. That was a little too crazy from what I was saying last week. So tonight we're basically going to be doing sorts. Now, I'm not going to be going deep on data structures, so we're going to be doing like sorting light. This is like enough sorting to get through C if you have an unsorted list. But in reality, never write your own sorts. This is a public service announcement. Never write your own sorts. They are out of sort. Oh my God, I can't believe I said that. Okay, so don't be out of sort with me here or her. She can be out of sort, but don't be out of sort. Do not write your own sorts. So this is for educational purposes only. We are growing herbs. And that's it. Okay, so this. Do not write your own sort. Always use a library. I have to caution that. I should have put it like big bold on the screen. Do not write your own sorts. Okay, so I think we've nailed that. Let's get down to business here. So we have our multi-userpad, which is open source, and of course we have a little bit extra on our window because that's fun. And we were just kind of getting warmed up. So I'm going to clear all that so that we can get ready. We were just taking a quick look at arrays with integers, and it's been a couple weeks, so we wanted to get fresh and good to go. So let's go find our glove and let's talk about sorting. Now, we're not going to assume heavy algorithmic stuff. This is really a class about C, not about algorithms. For what I'm showing you tonight, and this is very important, also part of why you should always use a library, these sorts should almost never be used in production code. So even if you had an off-the-shelf library that was tested, totally worked in every circumstance, stable, all the other properties I'm not going to talk about, don't use these sorts, okay? These are sorts that are really more useful for learning about sorting than they are for actually sorting. There are far more efficient sorts.
So you're teaching me like the bad sorts.
I'm teaching you the sorts that you gotta cut your teeth with, but these are not sorts you should really be using, or we would really be out of sorts. Okay, I'm gonna have to get myself a rim shot. So in the meantime, let's go look at the whiteboard and talk about topic, what are we on, 12? Topic 12. All right, so this is sorts. All right, well, sorting. What is sorting? Sorting is about taking a list of stuff and you're going to put it in order. So data arrives and it's in order, it's not in order. We have no idea what order, it's in random order. And we can make no assumption about what order it's in. So we need to take this collection, and that collection, that list in C is typically referred to as an array. So we're going to use array notation for it. And we need to, our task is to take this array of stuff and put it in order. So if we're just talking about integers here, so say we have a set of integers that are like, 7, 13, 8, I don't know. They're, whatever they are, they're not in order, okay? Then what we want to do, and however we want to accomplish it, we want as quickly as possible and in as few steps as possible to put this into something that makes more orderly sense. So in this case, I guess it would be 2, 7, 8. And of course, I'm cheating right now. I'm not using the algorithms that we're going to be talking about. I'm just sort of eyeing it up and saying, that 2, that's going to go over here. And that 7, that's going to go over here. So I guess if you had a neural network trained, you could do it the way that I just did visually. But normally...
That I can do.
Yep, that would be... let's just call the neural network version of this overkill. Let's say that we don't need to actually train any AI to do this. We're going to do this the old-fashioned way. Okay. Oh, and by the way, Loafbone asked, why not teach the ones that'll be used? The reason I'm not going to teach the ones that'll be used is because they're hundreds, sometimes thousands of lines long, and they really obfuscate sort of the principles of sorting and getting into sort of the algorithmic stuff. Now, what I am going to do is I'm going to show like kind of the sort basics, and so we're going to try to pick some kind of straightforward sorts that are not super efficient, but they're clear to understand, hopefully.
So here, though, right? Like, I kind of understand what you're saying about sorting things in sort of numerical order, but isn't sorting, and maybe I'm just getting a little too esoteric with it, but isn't that really relative? Like what order you want the numbers in? And I have been just. Totally. As a caveat, I've spent literally 8 to 9 hours today fighting with awful array stuff in Python. And so really trying to pick out what values I want or what things I want sorted it's relative, because sometimes you don't want the greatest number. You don't want the smallest number. You might be looking for something else.
That is absolutely true. That is absolutely true. So what you're referring to, you're talking about what order? Mm-hmm. And what order you want is called the collation order. And yeah, I mean, I didn't define it here. I just jumped right into what's called a min sort. This is, min sort. So I'm doing a minimum, you could say, numerical sort. So I'm just taking the lowest number and I'm putting it towards the beginning, highest numbers towards the end. But I mean, we could also do a max sort. I mean, and the thing is about sorting algorithms, it doesn't really matter, is the reality. Like, I need to have a collation order. It doesn't really matter to the sorting algorithm what the collation order is. It only matters that it exists. And there is a notion of what's called stable versus unstable. And this is getting a little bit into the computer science theory. So I don't know how far we should go down this, but
can you succinct? Because I'm sorry, that's really interesting, and I get what you're saying about a collation order needing to be specified. Is that a rule that when you're building these sorts, you can kind of specify that?
No, you have to. You have to. You cannot sort unless you know the collation order. You can't. Order is not strictly necessary. Usually we drop it in speech. We can just say like the collation, or you could just refer to it as the order. Pick one. But it must be defined what specific collation you care about for the particular problem you want. So, for example, if you wanted, this thing, in order of least to greatest, then that's kind of what I just did. So the collation order I chose was sort of minimum numerical is my collation function. I could flip that and say, I want it the other way. I want this thing to be, 13, 8, 7, 2. And that's fine, right? That's how I do that in terms of the sorting algorithm and that I'm going to just hand wave instead of defining. But how I do that is different from what collation I'm using. The collation is really my choice. So I get to pick what type of collation I want. My algorithm that I choose doesn't really care what choice I make. It just says as long as there's a definite collation.
So it's like collocation neutral, essentially.
Not 100% sure, but
okay. So it's
the algorithm itself doesn't care what your collation is.
So there aren't like certain sorts that are better suited for min sorting or max sorting or something like that.
No,
so they're
generally
neutral
not.
Towards
the
collation.
Almost all of them are neutral towards the collation. In fact, they usually some of them even specify like a collation function. So it'll say like, how do you want this collated? And
I see.
And by the way, the special class of sorting algorithms that we're going to be talking about are called comparison sorts. And that's important because in order to do a comparison sorting, I'm going to compare two of these values at a time. Now, which two and in what order and all that kind of gets into which algorithm we pick. But these are all going to be involve some sort of like, take this value, compare it to this value, which one, according to my collation function, which one is less or which one is more. So
what is the unstable and unstable distinction you mentioned earlier?
That's like I said, that's kind of getting a little bit esoteric. Stable and unstable have to do with when things are equal. So this is less relevant. So to the particular example I showed up here, it actually, there's no difference at all, because 7 is 7, right? So if I have, what happens if I have two 7s in this list? So it's like 7.
So which,
13,
even though their indices will be
7,
unique, the values
2.
of those indices will be the same.
Yeah.
So how do you sort
do they
them?
stay in the same spot, or do they move, but it doesn't matter because they're both the same value? So in our case, we don't care if they move because they're the same value. Now, that's not always true. Like, so if I'm sorting like dictionary entries, I might actually want them to stay exactly where they are in the case of equality. Like, so I might want this 7 to stay here versus that 7. Now, it's silly in the case of that I'm showing right here with numbers because it doesn't really 7's 7. So like they're totally identical in all regards. But in reality, sometimes they're not. Like I might have like records of like a name and a time. So like say like I'm saying like when a person came through a gate. So I might want to sort on time, like, but that's kind of not a good example. I'm just thinking that like, I might want to leave it so that like if I was sorting on name, like it would leave them in the original order that they occurred in, as opposed to changing their order, because the associated data is not the same. Right. So that's kind of getting a little bit into what stable and unstable means, but I'm not.
So essentially it's just, so without needing the specifics, it's basically, it's a property or a characteristic of the sort that has to do with how it handles equal values.
That's generally true. Yes. I like that. So we're going to go with that.
Okay.
And we're going to switch to green because now we're actually going to start sorting.
The best color.
So how do we actually go about sorting these things? Well, I mean, there's different ways. You're probably used to this from like poker. You can have cards in your hand, and you want to put them like, okay, I'm going to put the ace over here, and I'm going to put the the 7 over here. So like maybe I want my higher value cards to go over here. Maybe I want my lower ones here. Maybe I'm playing bridge and I want the lower ones to be on my left so that I can quickly access it. Again, collation is kind of like the sorting algorithm doesn't really care. It really just matters, like you need to specify upfront what type of sort, so what collation. Is this visible or is this like a really dark color?
I can see it very well.
Okay. Cool.
Yes.
No
so funny
problem.
story, really quick,
Yeah.
small interjection. It's funny that you bring up poker because poker is such an interesting game, especially from an AI perspective, because it's an imperfect information game. So, you don't know what your opponent has. And I know that's not your point, but it's funny that you bring up poker because I had to read
actually brought up
so
poker
much.
and bridge not accidentally because I chose two very interesting computational games.
It's very interesting, and I had to. So I've
They're both
maybe
quite
played
hard.
poker once, and I know like a full house is sort of, and I know that royal flush or something is really
Yep.
good, but
Yep.
it's very fascinating because I had to look up all of this really interesting like poker strategy and whatnot for. It was a lot of game theory and whatnot.
Oh, yeah.
For kind of teaching AI
Poker's
how to
great for
play
that.
games where you're making decisions, but based on imperfect information.
Yep.
And it's a very interesting problem.
It very much is. So, I mean, but again, like, so collation sort of depends on domain, right? Like, so in the case of cards, I've got these non-numerical things that have numerical values associated with them. Like, like ace usually picks up an 11 value, like in blackjack, but it could also pick up a 1 value. So which end do I put it on? I mean, it's kind of a mess in blackjack, but, or like, something like a king or a jack. Is a king greater than a jack? Well, it depends on the game that I'm playing. I mean, like in some games, these are both 10. In some games, like this jack is less than this king. And sometimes, like, so again, collation is outside of sorting. Okay, so you need to have your collation sorted out.
My God.
Oh my God.
Seriously, okay, so somebody in chat needs to start keeping track of the number of guy puns today. And there has to be some kind of penalty, like 8 swears or something, so I'm allowed to, I don't know.
Oh,
but
man.
You got to start getting, I think we're at 3 or 4.
3.
So really bad puns.
4 puns.
Someone has to keep track of this.
I'm putting ticks in the corner. I got it.
We need a pun bot, all right?
Yeah, we need
to have this be like something I can call in chat.
Pun bot. Okay, I kind of like where your head's at. I'm gonna write that down.
Yeah.
Let's
all the stuff that I never have time to build for my own channel.
Yeah, well,
so.
Hey, why don't you build it for my chat? Because you're coding.
There you go. Hey, all right. Okay. Can we do it in C?
We can do it in Python if we want to finish it.
Oh, yes, please. Can we do it in Python?
Oh, wait till we get the network code.
I can do so much Python in my sleep, like.
Yeah, that okay.
Yes,
so
I'm thinking. I'm in C mode. I promise.
We're gonna talk about PunBot later.
Semicolons.
So anyway. So we have a collation. You pick it. It's arbitrary to the sorting algorithm, but it's important that you have it before you start sorting. So see, I avoided the pun that time. You see that? I want to say you have it sorted out. I'm just going to strike that. Okay. So
actually, can we add, well, this might be a yes, no, but if it's a longer answer, we can add this to our topics for later.
Yep.
But would you ever consider teaching, like, not a Python for beginners, because I know you're doing Python for beginners and C as an additional language and things like that, but would you ever teach kind of like a, I don't know, intermediate or advanced Python?
Yeah, absolutely.
Okay. All right, we should talk about that.
We should. Because something like sorting algorithms, like if you wanted to get really in depth with sorting algorithms, you don't want to be messing around with memory. So like C is kind of a rough place to be studying sorting. So that's part of the reason we're trying to work with like the basic sorting algorithms and not get into like crazy stuff. But
so
like
even though these things, like you said, they're very common that you shouldn't build your own. You should get them out of the box.
Yes.
And
yes.
I think I've used a couple
Thank
of
you
different
for hearing that warning. Oh God, never use bubblesort. Don't ever use bubblesort.
What's interesting is like, so I was, in a job interview, and part of their sort of coding whiteboardy type interview was to build your own sorting algorithm.
Yeah, I hate when they do that.
It's amazing how disconnected those questions are often from the actual job. But
we're gonna talk about that at the break because I'm gonna get on the soapbox.
Oh yes.
So let's say whiteboard coding sorts. I'm gonna
ethically opposed to whiteboarding.
Yeah. And ethics. Okay, good. So, by the way, if you ever do get caught having a whiteboard a sorting algorithm just because somebody's evil, then you should use one of these sorts that I'm going through tonight because they're relatively easy to get right. I mean, no sort is really easy, but like these are on the easier end of like you want to aim for correctness rather than efficiency, because if the question's really efficiency, it's a stupid question because like import the right library and like it's like
I remember building my own and I had never done sorting algorithms before, but I was like, okay, I'm just gonna math my way through it.
Yep.
And I remember doing it, but
yeah,
yeah.
Yeah, but
It was fun.
and that is the right place to use a bubble sort, by the way, is like,
Okay.
that's one that's pretty easy to get right.
Also, it was a timed whiteboard interview.
Yeah, that's even worse. All right, okay, let's
Okay, all
don't
right.
get me
So,
into a
yes.
rage.
So-
Okay, so all right, we're back to sorting. So we're going to talk about two sorts up front, and hopefully I don't confuse them, because I always love to confuse them, and they're very close to each other. And these are the only two that we're going to be implementing tonight. After that, we're going to be using as a reach goal. We might reach for Quicksort, but we're not implementing it. We're just going to reach for it. Okay, so I'll get to that a little bit later. And which is, by the way, short for the Quicksort. And we're not going to do Tim sort, even if Nathaniel brings it up. I don't know if Nathaniel's here, but we're not doing Tim sort. But one of the funny things about Tim sort is actually, and this happens in Java as well, they fall back to insertion sort for small numbers of items. Because it turns out that despite the fact that insertion sort is not like one of the best sorting algorithms, it's actually still pretty performant in low amounts of data. So it turns out that a lot of these other more advanced sorts, they just require a lot of overhead to kind of get going. So unless you're working on a very big list, then it's kind of not worth it. Okay, so let's talk about these. Well,
You spoke and he showed up, by the way.
Nathaniel,
we were talking about you.
I invoked him. Nathaniel, I'm not doing Tim sort, just for Nathaniel reference. So we're not. I'm just going to head that one off.
I don't know what that is, but I'm sorry that you were deprived of the thing.
And you've been missing out on some high quality puns, which might have a different collation with the other person on this call. But anyway, so moving on, we are going to talk about insertion sort. Okay, so you already did bubble sort, you said?
In a panic at one point.
Okay.
Because it was easy and straightforward, and I just could.
It is easy and straightforward, and you should never use it.
Okay, good
except
to know.
Except for whiteboards. That
there was a whiteboard interview.
anybody who's evil enough to ask you a
Panic
whiteboard sorting question should deserve
You should design like a efficient and straightforward sorting algorithm that you just call the panic sort that people can use in whiteboard.
Oh no,
interviews.
we'll get to that. We can talk about the sleep sort, by the way, if you really want it. If you want to talk about some, they're called BOGO sorts, but they're sort of like ridiculously long runtime ways of sorting, but they're very funny. Anyway, so before we get to that and some of our favorite silly ones, if we're going to get this right, and I don't mix them up, so I'm going to try to look at my notes. I think selection sort is probably easier to describe, and insertion sort is easier to get right. So selection sort is sort of like, I select the lowest number, and that's my next one. So going back to my numbers, let's pick a few numbers. What do we have for? I don't know. I'll pick some numbers. Let's see. There's 7 viewers. I don't know.
So Nathaniel, we talked about it in very brief terms only. So my current understanding is that is a sort of like characteristic or property of sorting algorithms that has to do with how they handle values that are equal. And so we didn't go into it much more than that, just because I guess that's more like computer science and not as much C. So
yeah, it is. It's important, but Nathaniel is right to bring it up. So I mean, I would expect him to keep me honest. So all right, so let's just start with this array of numbers as sort of our example. And by the way, that's totally fine, CCV. In fact, I think we should start like a resistance movement for anybody who asks for a sorting algorithm on the board. We should always pick a sort and like just let's make up like chunk sort, and like, that's what they're going to get, because you really shouldn't be asked. If you're in an interview, do not ask people to implement a sort on a whiteboard. It's ridiculous.
Also, especially, I'm not a software developer, so especially to get that for me, I was like,
Team chunk.
What?
Yes.
And also, yes, team chunk. Okay, so
chunk.
Can you promise me one thing, guy?
Yeah.
So if I make it all the way through C, and I'm sticking with it, and I'm especially like we've talked projects and future goals and everything, and I'm like, being a good student and everything. Can you make like a cool chunk emote?
Yes, I will.
Yeah,
I will do that. There's one. There's one caveat to your request, which is that I'm not eligible for any more emotes. Okay. But I will make it my next one.
Okay.
If Twitch ever gives me one, but if you know what I can do, I can definitely put it in Discord. So we go. I can meet you there.
All right, that's a good compromise.
Yeah, we'll see if Twitch ever decides that they want to push live coding, then we'll worry about it then.
Chonk OS, I gotta
Chonk OS
build an operating system. Yes. That's what Dennis keeps threatening me with.
Yep, that's pretty cool. Okay, so we have these numbers. We have to put them in order now without developing complex visual stimulus and neural networks that can just see all the numbers and decide on what the right order is. How could we compare all of these things to each other and try to get them into the right order? Well, so like I was saying before, with selection sort, what we do is the gist of it is look at everything. And so we're going to start at the beginning. So we're going to look here. This is location 0. This is location 1, 2, 3. So we're going to look at location 0. We're going to say, well, we have nothing to compare it to. So let's compare it to 3. All right. Which of these is smaller?
Between 7 and 3?
Yep.
3.
Okay, so what we can do is we can start this off by saying, with our 7, we can say smallest is 7. Okay, so, and then we look at the second one. We look at location 1 and we say is 3 smaller than 7? Yes. Okay, so we're gonna strike 7 and we're gonna say the smallest is now 3. All right, is 3 smaller than 9? No.
Yes.
So
Wait, 3 is smaller than 9.
I mean, sorry, 3 is smaller than 9. I mean, we're not. 9 is not smaller than 3. I mean, sorry, my bad.
Oh God! Yep. All right.
Yep.
Now I really don't understand what's happening.
No. You're right. So 9 is bigger, so we're not going to call 9 the smallest. We're going to leave 3 as the smallest, right? Okay. So we're going to ignore 9, and then we're going to look at 8, and we're going to say, are you smaller than 3?
Mm-hmm. So you iterate through once you find the smallest thing and essentially just...
And we found it because we just went through the whole list and we said 3 was the smallest. So put 3 at the beginning.
Yep.
Okay, now hold, and the way we're going to do that is we're going to swap. So we're going to do it in place. I shouldn't be drawing this as a separate list. So we're going to take 7 and 3, and because 7 is in the spot that we want to put it in, right, the smallest spot, and we're going to swap them. So we're going to say this is 3 and this is 7. Okay, now we're going to hold that. We're going to say you're done, right? Because we know that you're the smallest one. Now, next smallest one. Load up the smallest again. We're going to load it up with 7 because that's what we're looking at here, right? And we're going to take 7 and we're going to compare it to 9. Is it smaller? Yes. Is it smaller than 8? Yes. 7 is your next smallest number, so we're going to leave it where it is. We're just going to move forward the list. Now we're going to take our smallest is 9. And we're going to compare it to the next entry, which is 8. Is 9 smaller than 8? No. So we're going to say, nope, our smallest is not 9. It's really 8. And now we're going to take this 8. And, well, we're done. We have nothing else to compare it to. So the next smallest one needs to be the 8. So we got to swap places with what's in the current, the place where we've been holding. So we're going to swap that. We're going to swap 8, 9. And we have one entry left. We have nothing to compare one entry to other than itself. And we know that it's not smaller than itself or not bigger than itself or not anything about itself. We're just not even going to compare it to itself. So we're just going to say this list is now sorted 3, 7, 8, 9. We did it by successively taking the smallest one. So we go through the list each time of what's not sorted. We say, okay, this is small. 3 is smallest. Then 7 is smallest. Then 8 is smallest. And then 9 is smallest. And we need to just make sure that they end up in the right spot. So we just have to be careful about our swaps. Make sense?
Yep. Yeah, okay. I think so.
Good. That's selection sort. So we do it because we select the smallest one.
Okay.
Great. And now the one that I always love to mix it up with, and Nathaniel will keep me honest if I do manage to mix them up, which is the insertion sort. All right. So insertion sort. The gist of insertion sort is of the ones that are sorted, where does the next one go? So if we start our list off, and I forgot exactly which numbers we had, so I'll just make up some new numbers. Do you want to make up numbers?
5, 11, 12, 17, 21.
Oh, going big, huh? Going for a bigger list, and you're putting two of them in order. Look at this. Okay, so these are.
I guess I should have.
I'm going to swap these just because.
Yeah.
Let's make this a little more fun. In
Oops.
fact, you know what? Let's swap. Let's add a little more disorder here. We'll leave 12. Kind of, it's doing the right thing. And then we're going to just swap 21 and 17. By the way, thank you, the only one Matt. I appreciate the follow. So, okay, here's our list of numbers. So we're going to forget about this. This didn't happen. Don't look at that. Okay. So this is our unsorted list. We're going to pick a collation order because we need to do that first, which is going to be... Hey, what's up, Cam? How you doing? I got power back, by the way. Cam has been following along. I've been posting on my Discord. I've been building a solar array with a couple photovoltaic cells and a charge controller and some batteries, and I managed to charge phone. I tried to stream off it, but it turned out everybody in the world switched over to the cell network and you could not stream on it. So Paul Blard Mald Cop. Sup, gamers? Yeah, Death Ray. Thanks, Jess, for the recommendation. Oh, cool. Oh,
Cool.
Only one Matt. Okay.
I don't, but hi.
Okay. Hi.
I made a recommendation. Sweet. Thank you for joining.
Okay.
I'm so bad with names. It's not personal, I promise.
Nope,
I barely
you're fine.
remember my own
You're fine.
Twitch name, so.
Okay, so from our original list, first thing we do, we pick a collation. So we're going to stay with the same one and say minimum. We want to do a min sort, min numerical again.
Yep.
You'll notice the only thing that changed to turn that into a max would be we just switch our comparison function.
Yeah, you just exactly.
Yeah. So that's literally the only thing that changed, and that's why I was saying like it doesn't. The sort algorithm itself doesn't really care what it is. No last miles, no bubble sort.
Apparently we're anti bubble sort here, Dennis.
No, we're anti all of these sorts. Actually, I told you, do not. Everybody, do not use this in production code. This is just for learning how sorting works. Okay, I don't want to catch any of you implementing this in real production code. Okay, all right. So minimum numerical. Okay, so we've chosen a collation order. We've said we're doing this, and yep, we're doing insertion. We just did selection last miles, by the way. You're doing a PR as we speak, really? Okay.
Oh boy.
I had better, Paul Blart, Mald Cop, I had better not see a selection or an insertion sort in that PR. No, we're not doing BOGO sorts. No.
Chat is taking over.
No, they're just, oh boy. Okay, so we're doing insertion sort. All right, so how do we do an insertion sort? The intuition was of the sorted, where does the next one go? So if we start off with our list, how many are sorted? Well, we trivially assume that the first one is sorted because a list of size 1 has only one sort order, right?
Yes.
Like, so if I just cover this up, and I don't have a good way to draw that without crossing it out. So if I just pretend that this part that's boxed is not there and my entire list is this 11, then I can say that this is sorted on its own.
Okay, I see what you're saying.
Okay.
I mean, it's kind of a little bit of a tautology, but yes.
Yeah, no, it is. It's
Okay.
very tautological. We just assume blindly that a list of size 1 is sorted. Okay.
Okay.
Seems like a reasonable assumption. Okay. No, we're gonna do Q sorts. Don't worry.
Oh.
No, we're not.
No.
You're just not gonna implement it. I'm not that evil.
Okay.
Okay. So, all right. Now I have a list of size 1. It's sorted. A list of size 2. So the goal with insertion is I find the place where this thing's gonna belong, and I put it there. I insert it. Okay. So I have the 5. I assume that my previous list, which has only one thing in it, the 11, is sorted. And now I want to grow my list by 1 entry to 2 entries. And where am I going to put the 5 in this sublist? So this sublist, which has currently only one thing in it, where do I put it? Well, I'm going to just look through the list. There's only one thing in the list. So I compare 5 to 11. and I realize that 11's sitting in the spot where 5 wants to be, right?
Okay.
So I'm going to trade them. So let's swap this and swap that. So we're going to do 5 and 11, and we're going to say that that's my whole list, is the 5 and the 11. Is this sorted right now?
Yes.
Yes. I'm always going to keep this part of the list sorted. Okay. Now I add a new entry, 12. And I say where, I'm going to compare the 12 to the 5. Is it smaller than that? No. Is the 12 smaller than the 11? No.
No.
So it turns out the 12 is already in the right spot. So I'm just going to leave it right there, and I'm going to grow my sorted list.
Yes.
Okay, so I've got 5, 11, 12, and now 21. This is my previously sorted. So 21, smaller than 5?
No.
Smaller than 11?
No.
Smaller than 12?
No.
All right, turns out it's actually in the right spot too. So the important thing here is I'm always keeping a sublist that's sorted, and I'm growing it by 1 entry each time. I'm inserting the next one.
Okay.
Okay, and now my last one up, I got the 17, so I've got 5, 11, 12, 21. 17 is going to ruin everything. Okay, so I've got my nice sorted sublist, and I take my 17 and I say, is it smaller than 5? No. Okay, is it smaller than 11?
No.
Nope. Smaller than 12?
Nope.
Nope. Smaller than 21?
Yes.
Okay, so what I'm going to need to do is cut a hole in here. And all of the things that are to the right of it are going to have to move over.
That sounds very un-C-like.
This is why I said that it's easier to describe insertion than selection, but it's harder to get right.
Of all the different ways you could do that in Python easily. But
Yep.
then
Yeah, it's a piece of
C
cake
is
in Python.
so restrictive, particular, maybe, that I just you casually say something like cutting a hole in this and just inserting it in, and thinking about that from a C perspective is like...
Yep, you're right. And by the way, I just saw Last Miles with his top-notch Belgian beer. He wants to see a Quicksort, so you might have. He's one of my subscribers. Quicksort. You might actually have to do this. I mean, this. And by the way, Last Miles, okay, you're in for. Let's see where we get. Okay, so I don't know if we're going to do clean Quicksort, but we might do some sort of Quicksort. Okay. So what I need to do to cut a hole, I can't cut a hole in memory, right? Like you're just intuiting. So what I need to do is I need to sort of like take this thing, put it on the side. I'm going to need to put that 17 somewhere else. And then what I need to do is I need to move every one of the entries that's in front of it over to make space so that there's somewhere to put that 17 in. Now, in this case, I've only got 1 entry I have to move over, so no big deal. I just take the 21 and I'm going to move it here, and then I'm going to take the 17, I'm going to slot it in there, and I end up with a final list of 5, I'll stay sideways, 11, 12, 17, 21. Okay. So I end up with a sorted list, but you'll notice it's just a little bit messier than selection in terms of, because of that little memory. Like if it was free to have holes in memory, then this would be a lot prettier. And
I mean, you could just, based on the size of the list that you're starting with, you can allocate the right memory, because it's not like that amount of memory is going to somehow change. You're going to have
that gets into how much memory do you want to throw away for your sort. So you can do something which is called an in-place sort, which is I'm only going to use the memory that's given to me by the list, versus like, I don't know what you want to call a non-in-place sort, an out-of-place sort. And that's just out of sorts. I couldn't resist it. Okay, what are we up to? 6? 1, 2, 3, 4, 5, 6. Yeah, okay, that was 6 bad puns. Okay, so
what's the penalty? Come on.
There's just no penalty. It's the penalties. Okay, so and an out of place sort is really like additional memory. So and that's kind of speaks to what you're talking about, which is if I can allocate another array to store my answers in, then I could be a little bit smarter about this, and I don't have to worry so much about swapping. But that's kind of the key takeaway to that. Oh, and I just saw last mile's.
There's arguments happening in chat about coding languages.
Oh, Python's fine. It's. Oh no. I just love how much you can get done with a couple lines of Python. That's one of my real loves of Python. But anyway, you, young lady, on the other hand, have some very fun times coming up because you're going to have to get both of these right. Okay, so how do you feel high level about these two algorithms? So
I feel fine about the first one. I feel icky about the second one from a C perspective. Like thinking ahead specifically about implementing it in C. Like both of these are sorts that, despite not knowing maybe the specific name, are sort of things that I've either seen or casually like. It would be very easy for me to do that in Python because that's just sort of my native language. But thinking about doing it in C specifically, I'm apprehensive about the insertion sort.
Okay. Well, then because you said that, let's do the selection sort first. I'll give you.
Yay! Okay. I thought you were gonna be like.
No. Sorting's hard. Sorting is hard enough to get right. So it's like one of those things. I got them wrong the first time I re-implemented them. I mean, I just had to I'm like, was I off by one? Damn it. Okay, so it's just there's plenty of things to be off. Now, just chat real quick. Can I get an F in the chat for Last Miles? Because Last Miles is dealing with this bit of a nightmare with NVIDIA kernel module loads. Looks like he's using the non-open source NVIDIA drivers. And thank you for the Fs. That's for Last Miles pain. And I appreciate that. I'm gonna throw an F there too for Last Miles. Okay, so Last Miles, we hear you. But that is neither here nor there, and Jessie does not need to worry about NVIDIA drivers right now. She's got to worry about C code.
I have done lots of that.
No. We're worried about C code. We're worried about C code, not NVIDIA drivers. So.
I don't know if that's a good thing or a bad thing.
Okay.
I don't know how I feel about that. All right.
Let's warm this up with let's just make the integer array. Let's just I don't know. Let's do like 5 entries in an integer array, and actually make Last Miles is having a bad day. So use a uint. Let's use uint 8t. Yeah. And just to be a little helpful, I'm going to give you that library. So this one's going out for Last Miles. So yeah, just pick an array for that, and we'll initialize it with some random numbers. Well, let's use these numbers. Let's use this example. We have 11, 5, 12, 21, 17. Okay, so before we really get into this, why don't we give ourselves a debugging routine? So let's have a function, and don't worry about, you can copy stuff on the stack all you want. We're not worried about memory efficiency at the moment. So let's just have a quick little display function that's going to just print out whatever's in the array right now.
So okay.
And get off that snake case. Come on, we're in C.
How do you do what's the C way?
Give me some camel case. It's actually C goes both ways, but we've been doing camel case.
That's both. Camel case is not. Wait. Thank you. All right. Okay. Let's see. Which, by the way, just saying, is less accessible for people with dyslexia. So you should use underscores. Python's more accessible. So people who hate Python. Anyway.
I did not know that.
Yeah. So
no, Nathaniel, no screaming camel case.
Yes, that one I'm a big fan of. I'll do that for everything. No. Okay. What am I doing? Okay, so it's going to take an array.
Uh-huh. So I can tell you right now that this you could just make it the same size. It's okay if you yeah you can. That's a little messier. So why don't you just make it a pointer, like a uint 8t pointer?
So that's just So
I know that I'm bringing pointers up, but it is C, so we gotta stay loose with our pointers. Yeah, it's gonna be some array, and we're gonna just for tonight we're gonna just know that there's only a fixed number in there, and we know what that number is in advance. So that number is gonna be 5 for now.
Mm-hmm.
So
let me think. Actually, so I'm gonna have it have 2, right? Because
oh yeah, you could pass it in.
Right.
Yeah, but if you're really gonna do that, then you gotta use the right type.
What?
Yeah, we use size T for that. Don't worry about it. You can.
Okay.
The size T
is comforting. This is my security blanket of a title.
So size T is
size T.
Everyone used to just specify like int, but they finally said let's just make a numerical type of integer which corresponds to however like array subscripts. Like so.
And what is the benefit of that as opposed to just
it's not platform specific. Well, sorry, it removes the platform knowledge that you would need. Like, is this a 32-bit system or a 64-bit system?
Okay.
It basically says that's none of your business. It's a size T.
Okay, that makes sense.
Yeah,
we can use that then. That makes sense.
It's just in our case, it's really just an unsigned integer, but.
Okay. So.
64-bit system, so it's unsigned long.
So many weeks.
You would use if you're doing proper size T stuff, then you would use size T for your loop iterand as well.
Really?
You got to be consistent. I'm totally fine with you. No, you know what?
Wait, how is that a size though? That makes
because we're gonna use it to subscript the array. Right, you're gonna use it to like index into the array.
I see what you're saying. Okay,
so
fine.
I don't care which one you use, but you got to be consistent.
All right. I'm staying in my happy place.
Yep, that's fine.
Okay. And then until this is less than or equal to.
Good luck, last miles. I'm crossing the fingers for you. There you go.
And then okay. Brain is slowing down.
That's
okay.
All right. We're just gonna get into it.
Oh no! Do I have to because it's a pointer? But wait, no. Hold on.
Yeah.
So no, we're fine because
we're fine.
That's fine, right? Because the first.
Yep.
An array is referred to anyway as a pointer to the first element in the array.
Yep.
Yes?
No
so
mental
we should
dialogue.
be fine to just index
code.
I believe.
Yep, you're right.
Right. Okay.
You are correct. So let's just test that out before we go anywhere with our sort stuff.
Okay. So do I have to put a return? I can't remember.
No, it does. No, it's void. Void is your return, so you're not actually.
Okay. Sweet. All right, so let's see. Let's print bonk. Bonk. And so. Oops.
And by the way, last miles, I think you were one of the early subscribers. I actually have some subscriber emotes coming shortly. We're just waiting for Twitch approval at the moment. I think there's a few in there that you're really going to enjoy, though. They're definitely programming humor.
Also, declaration. Did you mean printf? I did mean printf. What did I do wrong?
Well, let's take our errors one at a time. So.
Okay. Well, to me, did you mean, do I need to put an underscore before the U?
Oh, you know what? I gave you the wrong include because I'm a bad person. I meant to do this.
Okay. I was like, what did I do wrong? Okay.
Just bad guy.
But I did the exact same thing that I always do, which is ignore that. Don't look at it.
Oh, that's a nice emote you got there from.
That's an awesome emote, Dennis.
Beauty.
That is very nice.
I've been stressing about emotes all weekend.
I gave up being good at Twitch.
Just
people show up for what I do. Like I want to give.
No, I'm with you. I'm with you.
But...
I'm trying a little harder. I don't speak artistic language, so I was having a lot of trouble describing what I wanted. But I think some of the ones are. I think the programmers are gonna like them. So.
I feel you so much. Like I can appreciate good art, and I have enough of like a knowledge of art or music or something to appreciate when somebody else is talented at it.
Yep.
But nothing infuriates me more than just the casual way that people sometimes, like at work, for example, will just be like, well, do the thing, like make this artistic thing. And I'm just like, no, I'm a numbers person. Like you want me to like derive something? I'm your human.
Terrible.
But don't make me try to think about whether or not it looks good. I don't care about that. Like one of my best friends is an incredibly talented like UI graphic designer, and it's magic to me. It really is. That she could just walk in and just be like.
Well, I don't know if you noticed, but Last Miles actually just mentioned who did that wonderful emote, and I am writing it down because these artists, us programmers, we're like a dime a dozen these days. But
Mark Esserman isn't an artist; he's like a chess grandmaster.
Oh. He's
teaching Dennis chess.
That's
so
awesome. Oh, well, I guess I'm probably not going to be able to hire Mark Esserman.
I would not maybe reach out to him for graphic design.
Okay. All right. I was hoping there, I can tell you that the art that you're going to see is, I really have a thing for pixel art. So this is mostly pixel art stuff. So I love pixel art, but I'm having a lot of trouble finding pixel artists. Okay, so
that'd be a good place to ask.
I've been asking. I've been dropping in Discord. I drop in your Discord. I don't know. I'll drop here if anybody knows. Great. Oh, look at this. We're getting recommendations. Okay, I feel bad because I'm totally distracting you from
this is
the
fine.
bad stuff that's coming. I
need better emotes for my channel too, but. Somebody, Carson Druitt. Okay, Loafbone, make note of these people. At
the moment, I actually I'm out of emotes. So but that when you need to find these people, they're hard to find. So on the intertubes, nice. Okay, so we know that we can print things out. Great. Now all we have to do is write a function that's going to sort stuff.
Oh boy, I can't stop here. Like I can't just revel in the victory. I printed something.
Come on. You're at the end of your C class. You can print this out. It's a piece of cake. A little bit of pointer arithmetic, no problem. Now, listen. You don't need to return. Just to be nice, because I'm trying to be nice. You don't need to return the sorted list. So it's sufficient for you to just print out at the beginning of this function that you're about to write what the numbers are coming in, and then print out what they are at the end, but don't worry about returning them. So I'm not going to make you do a little extra pointer arithmetic for right now. Ship it. It's perfect. I care about making things look good. I'm still bad at. Yeah, Cynic Doki, I'm with you.
Also excellent name.
Really?
Yeah, so it's hold on.
I didn't follow
it's a sassy spelling of I thought it was synecdoche. So it's like it's basically where, how to explain it. It's kind of where you.
Man, you're digging deep just to get out of writing this sort, aren't you?
No. Sorry. So it's where like a specific term is used to refer to a collective. So like
like
you could
a plural
say
noun,
like
a murder of crows.
NVIDIA, or let's actually think of like Riot Games developed this game or something, or I'm trying to think of a good example, like where it actually refers to the team. So maybe sports. So like Boston won the latest hockey game, which I don't think they did.
That's a shame.
So there, it's not that Boston, the city, won it. It's synecdoche. So you're like referring to Boston, the team, the whole of the team as a collective, using the city where that team resides.
Oh, I did not know that word. That's a great word.
And I'm probably I'm very terrible.
No, but that's a great
pronouncing
word.
Words that I've only read, but I think that's what that means. But I also Dokie. I think that's what you're. Okay, maybe that's just the linguist to be flee desperately from.
is giving you a little up on the Nathaniel's definition, which matches what you're saying. So I'll buy it.
Linguistics
but you are not,
listen, again.
lady, you're not getting out of this. You're writing the sort algorithm.
All right. I feel like deserve poutine for this. A reward. A delicious reward or motivation. Okay, no, I'm doing this. All right, so this is the initial sort that we talked about. It was like the swapping sort.
You could pick. You want to go with selection. That's whatever you want to implement. One of those two. Any color you want, as long as it's black.
And you said, well, I'm gonna just do this for now. So. Sassy spelling. Yes. Sassy spellings I'm all about. Wait, Dennis, are you a hockey fan? I played ice hockey in college, and I am a huge Boston Bruins fan.
You're not getting out of this. You're not getting out of this.
Right.
You're not getting out of this. I want to see a sort. Any sort you want, but I want to see a sort.
But Mom, I want to play video games before my homework.
No. You have to write your video games before you get to play them. So let's get this sort.
This is nowhere near as fun as a video game.
You'll be sorting in video games all the time. I guarantee it. If you're ever programming one.
So Stropheme, unfortunately, we had to pause our game development lessons, but we did get most of the way through doing Pong, which was really fun.
Last miles. Hockey. Am I Canadian?
Well, you know, I didn't want to assume. I didn't want to stereotype you, but we should talk sometime about my very brief ice hockey.
Cam, you're absolutely right. I like that Henry Ford quote, the Hobson's choice. I'm a big fan. Any color you want, as long as it's black. Any sorting algorithm you want, as long as it's one of these two.
Oh, and low phone, why do you like the caps again? Oh, sass. Okay. All right. So we have an array.
Okay. Talk me through the intuition first. What do you want to do?
So what I'm thinking of is that I'm thinking about doing a for loop, and
don't get that specific. Start with what is the sort? Start with that. Rephrase the sort.
It's okay. So essentially, what you do is you start with the first member of the array, and you go through. And you see if it's the smallest. And if it's not, you replace the value with whatever the smallest is. At the end of that run, you know that the 0th element of your array will be that value. Then you take like 1 to the end of your, and then you go through and you iterate. You do that process of like finding the smallest.
So we need to know how many have already been sorted, right? Because we once we found the smallest, we don't want to reevaluate that one.
So I was thinking you could do that via...
I like the way you just said it, actually. The way you just said it implicitly does it. Okay.
So would you be willing to just talk to chat for a second and not look at the code editor?
I'll try not to.
Okay.
But I think you're going to want to start with, how do you find the smallest one? So I would just start with that. I won't look at the code as long as you focus on that first.
Oh, let's see. Okay. And you said there's like no Booleans in C.
Sure there are. You got Booleans.
You said no. That's one of the first things you told me, which is why I was
no
like,
Boolean
this
type.
is a terrible language.
Yeah, no, there's no Boolean type, but there's Boolean arithmetic. So you have all of the standard Boolean operators, if and or not, XOR, all that stuff.
All right, you talk to chat. Talk to them about.
Okay.
People are wearing pants. Please. All right. Okay.
All right. So... I'll talk to chat. Chat, how's it going? I'm not looking at the code, so it's just me not looking at the code.
Can I really quick? Can in the sort? Can I know the size of it or the length of it implicitly?
You can know the yes. Don't worry about. I don't want you to overcomplicate this. Well, we can modify our code later. Well, you're going to have to know how big.
Go talk to chat. It's
yeah, you don't even need to pass it in. I'm making life even easier for you. If you just hard code that it's 5, I'm fine with that. Okay, it's fine. I just don't want you to like juggle more variables than you need to. Like I want that working brain on one task, which is sorting. So,
I've got this. You talk
okay.
to chat.
Okay,
Right.
I'm talking to chat. Okay. Hi, guy. Focus here. Nice. Paul Blart, Mall Cop. Okay, so they're basically PJs. I don't count them as pants. I'm not going to touch that one. Love phone. There I go. Punning again. Trick question. What is the difference between these things? Okay. You're going to get some bad FOMO because I'm just like... I'm going to get to look at all these things. All right, so that's good. I like looking at last mile's screenshots because then I don't have to like see the code. Okay, so mismatching NVIDIA kernel module loaded. Yeah, and because the numbers are different, driver it's being installed 418.152 versus 450.57. It's not matched kernel version. Loaded 418.113. Yep, you got a mismatch here. And stuff won't work right. I'm going with that. I got you last month. Both cases. That may be. Okay, open a Nyan cat tab. I like your thought. I think I've seen not that cat. I always forget what that's called. Let's just there we go. That's what I'm looking at. Can I move it? I can't even move it. Come on. Wow. You've Nyan'd. Look at this beautiful bitmap font going on here. I like what's happening here. Let's see, did they use a real font? Or are they actually doing it? No, it is silkscreen. Okay. With a fallback to oh, nice. Monospace fallback. I like what's happening. Oh, got an error. Let's diagnose the error. Sound manager's not defined. Come on, bass. Play that funky music. I like how this person comments. But they're doing a dot accessor on something that's not there. Naughty, naughty. Oh, this is hand-coded. It's not minified. Look at this wonder. Oh, God. Come on. Come on.
You're not talking about me, right?
No.
Okay, all right, you're fine. You're just like, you hear this like, oh, God, this is terrible.
Oh,
I'm
my
like, oh, no.
goodness.
I'm just thinking right now. I'll make it better in a second. Okay, all right.
No!
I don't want to.
Oh,
do
no!
Big nested for loops. Okay.
I'm putting this in a code WTF. This is epic.
Poop.
What we just
I don't
found
think
here.
I have a choice.
Dropping it.
I don't think I have a choice.
I don't even have
some fancy function. Maybe I'll do that.
Code. We need a code WTF channel. What am I thinking?
No. Oh, I want to talk to myself. Okay. Can you mute? I'll mute myself for a second.
I can mute. You want? No, yeah, you do it, because that way you know when to unmute. Okay, your message. Don't upload it. Oh, come on. The code. It's so bad. So for those of you who don't know, I'm putting this in my Discord, which I think the bot is up. I want to say the bot is up. The bot is up. Okay, so I just added a code WTF channel, but clearly we're going to have to do a little work because it's just amazing. I'm amazed. I don't know what to say. She's cursing a lot. Nice. Okay, welcome. Yeah, where's my wave? There's my wave. All right, so I don't know how much I should be talking because if she can hear me, it's probably distracting. It's not helpful. Aren't we supposed to ASMR this stream? Sort the variables. Swap in place. Don't write a bubble sort. She is totally okay. That's not a cat. This is a cat. That's a cat. I'm going to have to go ahead and agree with Last Miles on that one. It's running, so it's perfect. Nice, Paul Blart. Code judgment. That's what we're trying to avoid. Don't judge the code. That's rude. I know I should. Yeah, but you code WTFs, they're special. They have to be recorded. What is that? Grab code and copy and paste from? I don't know what happened in that code, Last Miles. Oh, let's see. So can you do a quick explanation of what they are doing with all? I don't think you want me to explain this, Cam, because this is a bit of a diseased. I don't know why they wrote this. Like this could be totally just lols reasons, but I have to analyze the whole program to know. Oh man. So the thing is, you never want to be in this. This is a bad place to be. Okay, like you want an array, of some sort, and you want to just. I mean, look at all the opportunities you have here for like misspelling or, like, who's going to check this? Not to mention, like, I mean, the code smell right off the bat is when you're past like 4 indents, something bad happened usually. And this isn't just a little past 4 indent. This is like indent land. This is the pyramid of hell. This is actually it. Let's see if somebody has said this better than me. So I guess that's a little too generic. That's callback hell, the pyramid of doom. You don't want this. See this here's your pyramid here, over here on the. You don't want to build pyramids. Pyramids are bad. You want to start breaking stuff up. Now it's usually this is better, right? 4 indents, you're all right. I do mention this on regex licensing. So if you come over here and you see the anti-pattern, oh, I didn't put on anti-patterns. If you go here, first rule of advice, going past 4 indents, bad idea. Like that's a big code smell right there. Ness Floruti. Thank you for the follow. I appreciate it. What's this channel about? Just general live coding. Kinglentine. It's this general live coding. Tonight on Tuesdays we do C as an additional language. So Jessie up there is suffering with her first C sort. She's implementing a sorting algorithm right now. And wow, that's a wall of text just happened. I just had a sick and perverted job contract where someone wanted me to take code out of an Excel spreadsheet and turn it into an Apache WebMagic thingy, wherein they hit a web page and enter numbers, and then the computation happens in the JS front end as well. Oh no, she looks like she's suffering. We should check on her. Okay, no, she's shaking it off. She's okay. All right, so we're gonna. Okay, she might be happy. Camera went out of focus. Nope, looking good. Okay, so happens that in a JS front end as well as on the submit backend in MySQL database. Yeah, that's back in the day. They were all like that, and it was a terrible time. Last Miles. We try not to remember that time. It's horrific to unzip the Excel files into their XML data pack to get the formulae, of which there were many hundreds. This is why I have all the gray hair. Nice one, Last Miles. And I very much love the emotes. Wonderful. We watched 9cat and judge some poor kids' JavaScript code. Paul Blart, I am not judging that harshly here. You want to see somebody who just like harshed somebody's code, like the worst code review ever. This was just like top page. I think it was like front page of Reddit. You know what? I'm gonna pull it because it is really something else. I mean, just the URL alone tells a story. I'm gonna get rid of that. And reviewing the worst piece of code ever. This is it. So I am not harshing anyone like this. I mean, this is rough. I mean, this site has been knocked over. It was so popular. Okay, but anyway, you can all check it out on your own. Oh no, here it is. That's it. This is like everyone's favorite line right here. If true, smart quotes too, is equal to true, return false. I don't even want to know. I don't even want to know. This was actually hard to read. Anyway, so going back to channel. You're cyberbullying at this point. No, come on, Paul Blart. Oh, there's been some wildly bitter code reviews on Slashdot back in the day. Slashdot's still live, and I have a 20-year-old account. If I could recall the password, still have my Slashdot account. I plan on writing code like that in my college class. That's cool. Wow, that is a low-numbered Slashdot ID. Hey, what's up, Jane? How you doing? Jiggity Jane showed up. Paul Blart, by the way, I really don't generally care. I mean, so code quality to me matters a lot more when you're working in a team. Like if you're just sort of hacking stuff together, like, I mean, whatever, you know, I really don't care. But like when you're trying to write stuff, like part of what I was throwing in and advice is not to be harsh. It's like just a few quick rules that'll keep you from the dark side. Like I've seen some stuff, and this one came about because I was working on a piece of code that they had actually gone so far over that they ran out of space in a 132 column IDE, and they went back. They just dropped the indent all the way back and went all the way over. So it was actually like 260, like it was massive level of indent. Now, I have to say that is not, that's bad. Like you're going past like so like a good rule is like, you know, I try to keep my functions to like a page, and I try to keep my indents to like 4. But I mean, you know, like code that works. Okay, we've let Jesse suffer long enough. So Jesse, we're gonna have to tune back in. We're gonna have to help. That amateur's got to go with the ultra wide monitor. Ronan, I'm on a ultra wide right now. No, I haven't. Wait. No, you don't torture yourself and sell it a source. We're allowed to do this together. It's a pair coding. You're muted. I'm shutting up. Okay, she's telling me to shut up. Almost all of the Linux kernel and OpenSSL, only Apache HPG has max indent. Yeah, last mile. That's a good practice, because I feel like it's not that I'm such a stickler for like a care. I care that the code is almost definitely full of errors at that point, because you're just sort of like, you're hurting human. The stuff that I hate the most in code is the stuff that hurts human reasoning. Like you want code to be readable by people. And I understand that sometimes you're writing stuff rushing, you're in a hack day, you're on a terrible deadline, you're just trying to get something to work. I get all that. And I'm very forgiving to people about that in code reviews. You know, I'll even say to them, like, if it's something like really egregious, I'm like, just throw it to do on it. Oh, she's looking happy. I think she's looking happy.
I also have to use the bathroom, so I'll be right back.
Okay, you go do that.
But you look at that, and it's probably terrible, but it works. So, first steps.
Yes. And last miles, that's completely how I feel about it. And it's not about shaming to me. It's about like, just write code sane. Like, because if you're hurting everyone's reasoning, you're probably getting it wrong too. You're like it. Anyway, also it depends on, I mean, if you're just, of course they say like there's no more permanent code than something that's written as a quick fix, temporary hack. Are we going to unit test our code with different set of input? Yes, Nathaniel, I think we are. Let's see. So it isn't every man for himself. No, Kim. Okay, I'm hanging on here, having a pending reboot and another beer. Yep, this is a good time to get that reboot out of the way. Okay, she's getting mad at the code. Yeah, I think there was some great stuff on the video there. She's almost there. You can see it. Nice. Okay, sorry if I missed some stuff there in chat. if true. Yeah. Actually, last mile's code. Yeah, when I saw that line of code, I was like, whoa. That's okay. The funny thing was I saw that post, and then I saw the other post. I don't know if you've all seen the meme. Like somebody said, like another. I think it was on Reddit. I got it from a friend, but they said you should. It was something like, oh yeah, it was bus factor. I don't know if you've heard about bus factor in software. You actually, the experienced of you probably all have heard it, but bus factor is like, like if people get hit by a bus, like could you maintain the code base and all that? And so this guy was attacking that myth, and he just comes out and says like, it's not bus factor you have to worry about. It's Netflix hiring your engineer from under you that you have to worry about. And my first reaction when I read the article, I was like, do you think we have standards so low that we just hire anybody? Because I had just seen like the terrible code from that other post, like back to back. I'm like, you don't have to. All right. Anyway.
Hi. So this is definitely like brute force method. So I'm not trying to claim that this is like, I just wanted to get it working.
That doesn't look like brute force. Brute force, you would actually write every single line. Like if this one's less than this one, if this.
I mean, it's kind of like, I'm sure there's more elegant ways of doing it, but like my first pass whenever I'm writing something is just get it working, and then I can like
that's
make
good.
It pretty after.
That's good.
So,
okay, so walk me through. What are we seeing? So it looks like they're sorted on the left.
Okay, so what I was thinking is that really what you're talking about, and I'm sure there's better ways to do it, but the way that I was thinking is when you describe verbally how this sort works. Mm-hmm. You actually have two things that you're looping. You have overall like what particular index of the array that you're considering. So in the first pass, right, we consider the 0th element and we want to compare. And then you consider the first element and then you want to compare. Well, even in the way that I'm saying it, like element and then, the and then part is the second loop. And so you pick, the first loop just goes through and selects what item you're going to be comparing. Mm-hmm. And the second loop is the one that goes through and does the compare.
Okay.
So in this sort bonk,
so that's how you're holding the list of what's already sorted.
Yes.
Okay.
So this is the first sort that we talked about, not the second one.
Okay.
The comparison sort, not the insertion sort.
Yep, this is the selection sort. No, they're both comparison sorts, but that was selection is
whatever.
Yeah, selection. You're selecting the smallest one.
Yes. So. All right. So where was I? Right. So that creates whatever element is going to be compared. That's the first loop. So that's the loop that starts on line 11. Mm-hmm. That's just going to go through every single member of this array or of this list and select basically the next one, the one that we're going to compare. And the next loop, which starts on line 15, goes through starting at whatever element you've picked. So actually, to speed this up, hold on.
Well, yeah, you don't prematurely optimize. It's better to be right.
No, okay, all right. We'll leave it.
Leave it. Don't worry about speeding it up. Yeah, just walk me through it.
Because I think there's like an extra loop in there that we could cut. But anyway, so it starts at, but I want to. Okay, no, I'm focused. All right.
Nope.
So
there probably should be 2 loops, by the way, for this. So don't.
Okay. Okay.
Don't over optimize right now.
I think that this should start at start plus 1, not start. Because it self-checks for the first one. Yeah, so that was just
a little tweak.
That was all. So it was me being, but so
talk me through it. So the first one.
So the second loop, once we've already selected our element,
it picks the first one.
Mm-hmm. Yes.
And then it starts chooses at the next one.
Then it starts at.
It's going to go through all of these.
N plus 1.
Okay.
And then it goes through each of them, comparing it to n. And if it's less, it swaps them.
Wait a minute. You had it at start. Okay, so you want to use. Okay, so you want bonk is going to be smallest in this case.
Ideally, that's the.
The goal is to get bonk to be smallest. Okay.
Yes.
Okay.
And so we go through. And you start at the next one right after bonk, and you iterate through this list or array or whatever
up to the end. We keep going.
And if you find an element that is less, so it's smaller than bonk, you create a placeholder that is that
Yep.
that is the value of that thing, and then you just swap them.
Uh-huh. Now, by the way, it doesn't really allocate this every time, right? You're just using a convenience syntax, right? This could be, it's just on the stack. So like
Yeah.
You could put this like up here, right?
Yeah.
Because
definitely.
it's really just one piece of memory, but you're not worried about that. You scope it to here, so that way
that's gonna take more time to like.
No.
allocate
It actually the
each time,
compiler's
then we
gonna the compiler's actually gonna unroll it to be equivalent, but
Okay.
it's only gonna take one chunk of memory. But the nice thing is that putting it in here, it doesn't allocate it every time you loop, every time you hit this if, but it does
only
scope
if
it.
it meets the criteria.
It scopes it to just this piece, so I can't refer to placeholder outside. So it's really just being used for the swap operation. And what you do for the swap is you take bonk and you chuck it in placeholder, then you take bonk and you give it what was in array, and then you take array and you give it what was in placeholder, so you end up effectively swapping the two.
Yep.
And that way you end up with the smaller one is now back in bonk. So bonk is always holding the smallest one, and then we say here array start
Is so, because, all right, how to put this. So if you imagine that for the list, I wish I could draw on the drawing pad. If you imagine that our list, right, 11, 5, 12, 21, 17. If instead we have 5, 11, and we're dealing with 12, 21, 17. So we've already sorted 5 and 11. Or let's say we've already sorted 5 and we're working with 11. So the reason why you need to change array start to bonk is because you're going to take 11, right? You're going to assume, you make the assumption, right? And that happens in line 13. You make the assumption that this is the smallest element. Then you go through and you check. And you might replace it with the smallest element, but because you're doing that swap, that becomes the new min.
All right,
Like that
so you're
becomes
sort of
the
throwing
new
it out.
index.
You're disregarding what is there. Yeah, okay.
Yeah, but we've already swapped.
But
so
you're
that's
remembering to put it back at the end, so that's okay.
Exactly.
Okay. And when we print it out, it looked good or bad?
It looked good.
Okay. So I'm going to just
haven't
modify your
completely
code
lost my
a little
way
bit. I'm just going to add in
The original.
the original so that we see it beforehand and we see it after. And just because we're nice people, we're going to throw an extra new line there at the end so that they separate themselves out in the output. Okay, so if we execute that, we see that we fed it 11, 5, 12, 21, 17, which is what we said. And we got back out 5, 11, 12, 17, 21. So it worked for our list of 5 numbers. Therefore, it's totally perfect. And we're going to ship it, as Paul Blart Maldcott said. There couldn't be anything wrong with this algorithm, correct?
Oh, no. I mean, it's probably plenty of things wrong.
Well, it looks right for our one test case. So therefore, it must be perfect, right?
Oh, God. Well, that sounds like some logic I'm having to deal with in other arenas of my...
Nathaniel, you're correct. There are some extra swaps there. I'm not.
Are there? Okay.
I'm not worried about that. That is. In our case, swaps. These are effectively going to be registers. So like any sort of optimizing compiler is going to probably throw that out. If swapping is expensive, then we care more.
Okay.
But that's okay. Now, so let's see what happens if we change the input.
Okay.
So let's start off by adding a few more things. So I don't know, 23 and 14 and 297, because we're just about to hit 300 viewers, 300 followers, but actually we're not allowed to do that because this is a uint 8, so we're going to stay below that. So let's just do like 207 and I don't know, there's 5 of these and then there's 10 of those, and what other numbers are on my screen? Does somebody have a number in their screen name? Can we see? I'm not seeing any numbers.
Any numbers?
Okay, you're all like
we have...
pure name people. You just...
Do we have 3? That's how old Hubble is.
3? Okay, let's get a 3 in there. Oh, 42 should be in there because, thank you, that just should be there.
Because reasons.
Okay,
Yeah.
now before we go too crazy, how many of these are we adding? That's 4, 4, 4. So we're going to say that there's 12 of these, right? Does it match your math?
Okay. Yeah, 12.
Okay, so let's change that to 12. Let's change len bonk that you set here to 12. And And we're passing in len bonk, so we should be all right, right?
Mm-hmm.
Okay, so now you'll notice we have one equality in here. So is that going to spell doom? I don't know.
Probably. I didn't write anything to handle that.
Oh, don't worry about it. Okay, so we run this thing, and it didn't crash. That's a good sign. Of course, I told you in C, you're lucky when it crashes.
Ha! It's sorted.
Did it sort? 3.
Look at that. Yes, it did. Yeah, it did. It sorted it.
That looks good. Now, what if we?
So there you go.
What if we have something? Are we worried about our last terminal value? What if this was an 11 and this was a 42? Let's just check that real quick, and we're gonna clear this. And oh, okay.
Hey.
It's looking good. It's looking good.
There you go. All right.
By the way, Last Miles, thank you for the sub. You now get a subscriber badge when you write something, because I finally updated these things. I'm back with fresh toasty warm Mozilla and a cold Belgian Leffe. Oh, I like Leffe. It's a nice one. Beer and even wearing pants. I see sort works. Yay! She won. She's Netflix ready. She might be Netflix ready. Unlike the earlier story, it got
not in C. I feel very confident in Python probably. But
why don't I have a badge? Sorry, Loafbone, you gotta be a subscriber. They're subscriber badges. Ship it. Except
it says 2-month subscriber, so he's got like this first thing next to his name. So maybe that's why.
Founder. Oh yeah, he actually is the first. He was the first subscriber, period. So he gets a badge that no one's ever going to get.
There you go.
But you will have some access to a few cool emotes when they finally get approved. So you are the foundation sub. I appreciate that, Last Miles. Heck yes. And by the way, King Linteen, thank you for the follow as well. And there's some happiness going on. Somebody does have some emotes. Okay, that was Twitch because it's Pride, but yeah, cheers is later. Okay.
All right, yes, I'm focused.
Okay.
So I recognize that, like I said, if this were me coding for something that was not where people were watching, that would be first pass, and then I kind of iterate on it and make it better and catch things and whatnot, and I go through it. So like this was definitely like the rough draft.
This is better than a rough draft. It's correct. And actually, you should always aim for correct first. Do not prematurely optimize. Premature optimization is the root of all evil. Remember Knuth.
Oh, I definitely don't do that. So
okay.
It's got to work first before I start.
Of course you don't. You program in Python. So, you're like me.
Actually, so did you know? Technically speaking, my first programming language I think is MATLAB.
Okay.
My high school was the only high school in the country at the time that taught MATLAB.
MATLAB is an expensive site license, so I like your high school.
It was a bunch of rich, snooty private school kids and then scholarship kids. Woohoo!
Nice.
So,
all right. Well, this is looking pretty good. We could torture your algorithm a little bit and give it some pathological cases, like what if the length was 1?
Okay.
I don't want to find out what's going to happen. So, like, you could check all of the bounds cases and you'd be fine. Some of the other sorts that we could talk about is like what happens if all of these things are already sorted and it was already in order. Does it leave it undisturbed? Is it faster or slower? And is it if it's in reverse order? Same story.
I find that it would be almost useful to have like an is sorted function if we were to write that, and it would check. And so that could be really useful just as a check in the beginning so that it wouldn't even run unless that failed the initial check.
We got a timeline though. We got stuff to get through.
I know. I'm just saying.
I was having enough trouble getting you to write the sort, and look at that, you knocked it out, no problem.
See,
no
the
problem.
Magic happens. So seriously, the magic happens. If I take off my headphones, I mute myself so I can talk to myself like a total weirdo.
Yeah, you don't need to hear me talking to chat.
Especially if I get my awesome headphones that are noise canceling and I blast obnoxious music, then it's like I'm the best coder ever.
Nice.
It's amazing.
Good work.
Like,
well,
not really,
before we go saying awesome. Before we go saying best coder ever.
No. I was being facetious.
I know. I'm kidding.
It is amazing how much music does help.
It is good to get a sort right. It does. It feels good, doesn't it? Doesn't it feel? Doesn't feel good? All right,
it feels good to get anything right.
You went from algorithm to implementation right there. Beautiful.
Well, you know what? If I write C code and it works, I feel great.
I'm going to give you a choice. So
Yeah.
this is your decision point.
Okay.
We probably don't have enough time to do both. So
Okay.
would you like to take a crack at insertion sort and implement it? Or would you like to take a look at Quicksort, which is going to be a library routine, which we're not going to implement, and take a look at some of the other stuff, talk a little bit about algorithmic complexity and the other topics?
Probably. So conceptually, I know we're still working through like how I can work on stuff on my own time. But I would love to learn more of the latter because
I agree, and I would say that
Yeah.
like the other stuff is probably better as like homework than it is as like, because I think once you got the idea behind a key sort, any of them, bubble sort, selection sort, insertion sort, it's just
Then
a
it's
matter
just
of kind
move
of
on.
getting the code right, which is a good exercise, but it's not necessarily something we need to do like now. I think you'll get more out of if we talk about the other stuff. So let's do that.
Okay.
So unlike Last Miles, who's really raring to go on Q-sort, and I am not willing to torture you that much.
Like I said, I spent all day with like Q values and stuff like that. So Q sort just, I'm like, no more Qs. No more Qs.
Okay. Now, they're also mentioning some O notation in there. And
Yes.
I'm going to guess that you haven't probably
Big O
seen
notation.
much of this.
Yes. No, wait, have or have not?
I'm going to guess you have not.
So I'm familiar with, like, I know what it means, and I know when, especially, so I've had a lot of work projects on big data, and so, your big O notation, or however you want to say it, becomes really important in terms of your runtime, and so
Yeah, it is.
I'm
It's all
familiar
about
with the
runtime.
concept. I
So
know
we're
what
going
it
to talk
means.
briefly about that, but I am going to say that before he runs, Cam is working on the Ben Eater build a 6502 computer from scratch. They have it. Ben Eater has a breadboard kit that you can get, and he's been doing a little bit of hardware and assembly, which I think is also kind of a fun
Tacos
thing to do.
sound awesome, also.
So, and tacos, of course, sound
Enjoy
good.
your
So that's
tacos.
his EEPROM, and that's kind of what he's doing over there. So who is also computers? Oh, that's interesting, Last Miles. Thank you for the cheer as well. I think you really got to cheer Enceladsaurus for that one. I feel like she nailed it. But, okay, so let's talk a little bit about runtime. Yeah, Ben Eater, Cam mentioned Ben Eater, and I just recently resaw when Cam mentioned with the 6502 kit. 6502, by the way, is a processor. It's really cool. It's old school. It runs it was very popular. It's from Moss, which was anyway, getting far afield. This is really a discussion topic if we want to get into the 6502 and why it's so cool. So I'll just drop that on as a just in case. Okay, actually we have a lot of discussion topics, so we need to just move right along. Okay, but I do
Yes,
appreciate the bits. Thank you.
So for the big O stuff, I feel very good about that. So
Okay, well then I'm not going to go into too much detail, but basically the gist of it is like how many comparisons did you have to make in order to sort an array of a given size? So if the array is like n entries, like how many times did you have to look at every key in order to be able to get it right? And
Right.
it's order of magnitude, so we're not specifically worried about whatever coefficient might be in front of it. It's going to be some coefficient times n. We're really worried about what sort of power it is, and we're not worried about this thing. So that's the super short version of that. We're going to get into that more in the algorithms class. So we'll do that if we go on to data structures and algorithms. Okay, so I'm not going to get too specific, but these sorts that you're studying right now, these basic sorts, they're all n squared algorithms. So this is big O of n squared. This is important because it means that for a list of size n, you could look at n times n entries in order to be able to get it into order. And in reality, it's always going to be a little bit worse because it's however many swaps and other stuff that you're doing in there, which is part of why Nathaniel was worried about it up front. But order of magnitude of this, when it's sort of optimally implemented, is n squared. So both selection that we just mentioned, that you just implemented, insertion, and bubble sort, incidentally, are all in this class. So these are all n squared. And by the way, I forgot to cut over to the whiteboard, so I'm going to do that. So these are all n times n or n squared algorithms. Now, you should really, there's no excuse ever for you to use this in production code because there are better versions of comparison sorts, and some of the best ones are approximately n log n. Okay. So they're a little, this log n is obviously going to be less than a full n because it's the log of n. So this would be a more optimal version of it. So n log n is, less than n squared. So you should really never be using one of these outside of like you're just focusing on learning about sorting and stuff like that. But so don't ever use an n squared algorithm. There's always a n log n algorithm, and the one exception to that, which I will allow, is the Quicksort. And the Quicksort is a little bit funny because it's a very popular sorting algorithm, and it involves partitioning the space. So basically what you do is you take the stuff, you split it some arbitrary place, doesn't really matter where you put. That's called the pivot. I'm not explaining this very well because I don't really want you to implement it. All you really need to know is that it starts with the word quick, which is important. So we pick an arbitrary, just to make this clear, you can pick an arbitrary pivot. Pivot does not need to be in the middle. It's not a bisection. So wherever you happen to pick the pivot, you compare all of the entries to the pivot, and usually you start with a sublet. There's different spins on how you do this, but you're kind of like saying, okay, are things, is each entry bigger or smaller than the pivot? Does it go on the left side or does it go on the right side? And we're going to kind of put them in the right place, and then what we do is we sort of keep subdividing our list. So you can say, okay, this list now we're going to kind of like pivot that, and anyway. I'm doing the really hand-wavy version of the Quicksort algorithm. Okay. In reality, the pivot you generally choose is typically the first one that suffers from worst case n squared if you give it what's called pathological input. So if you hand it a already sorted list, then it'll always pick the worst pivot and bad stuff happens. And nice, I will give you a directory listing last miles if you want one in here.
Also, yes. Can I tell you how many freaking times in like work Slack, awkward like group chats that maybe that isn't the best place, I've done like ls or whatever it was I was meaning to type in the terminal, and then you click it and you just feel like a complete...
Even better is when you type this command, the who am I command, because you're, say, checking which user you're logged in to be doing something. And then that's really awkward in the modern era. You're just like, who am I? People are like, I'm not going to get into that guy. That's just, that's a question you're going to need to answer.
how awkward and sort of like, I don't know, newbie-ish I feel with C. Similarly, I've had to, my development environment for one project requires Windows, and I literally pulled up the command prompt or whatever it's called, and I have never felt more incompetent in my life. I've been on Unix for so many years at this point that I was just like, so many astrophysics software require Unix. And so I pulled it up and I was just like, LS. And it was like, nope, what's that? And I literally all, confidence and self awesomeness sort of drained away slowly.
Oh,
but
that's
okay, because you know what? I'm learning C, and similarly, I unfortunately am.
This is from a group of people that flipped the front slash to being a backslash just to be different.
Just to be jerks, because that's really annoying.
It was, and it was done on purpose. Anyway, so we're not going to get into that. And
okay, let's add that to the drinking topic.
If we want to open the haterade on DOS, then I'm all for that. But that is like,
we can open the haterade on Windows.
We can open the haterade on that. So
let's do that.
Okay.
Anyway, yes, Quicksort, hand wavy.
Okay, so Quicksort, we're doing a real big hand wave. So I guess the right way to do that is we're just gonna. And I'm going to give you a few wave things. All right, so that's the hand wave. That's the big hand wave. Okay.
Okay.
We're gonna get rid of that because it really looks like I'm flipping you off. Okay, so anyway, we're back to quick sorting, and this is sort of a very useful algorithm. It's not the important thing, and I'm sort of hand waving this. The runtime is generally O of n log n. In its average case, it depends on the input. In its worst case, it's an n-squared algorithm. So in its worst case, and you really have to,
same as the other ones that
you have to rig the input to do it, but in its worst case, it actually is an n-squared. So this is sort of a trick question that shows up on interviews sometimes, like, oh, well, what's the runtime of Quicksort? Well, it turns out there's
a lot for this. A lot of them. There's best case, worst case.
Yeah, well, that's where I mean, like versus like the algorithms that you were doing, which basically they're going to be n-squared every time. Yeah. Like pretty much guaranteed. But like this one typically is n log n, and that's pretty good for a lot of data sets. Now, you have a few other options. You can have an algorithm that's guaranteed to be n log n. Okay. And part of the problem with it, there isn't like a great one, because typically you have to throw away n squared memory. So, you can have CPU as n log n, and you can have n squared memory, and this or you can there's typically a trade that you're gonna make somewhere. There's no perfect one size fits all sorting algorithm. TimSort that Nathaniel has mentioned is actually pretty damn good. If you don't know what the input is going to be, if you don't know what you're going to be sorting and all that other stuff, this is one of the best ones out there, and that's why it's built into things like Python and other languages. But so when you're actually typing sort, you're getting this under the hood, and a lot of these algorithms, they sort of fall, they're hybrids, so they involve a bit more setup. So like you might have something that like it'll do something like merge sort, and I'm going to type that better. So there's merge sort, which is really easy to describe. I'm really this is the algorithms class, so that's why I'm sort of hand waving a lot of this stuff. But merge sort is sort of like a process of like, if I
subscribe and follow for more classes.
Yeah, we'll be doing that in the not
like
see
if
as
you really want to know what's going on.
If you really want, I'm totally selling this wrong. You are absolutely, if you want to know out there how to do this, I want to know everything, then you're going to want to show up for level 2. Okay, no, but a really fast version of it for merge sort is you basically just cut it in half and you sort each of the pieces.
Okay.
And then you cut that in half and you sort each of the pieces. And sooner or later, if you do this enough times, you're going to end up in a pathological merge sort, which is almost never implemented that way. Then you're going to end up with entry size of 1. And we know that entry size of 1 is trivially sorted. So if I split this enough times, and by the way, you have to deal with like odd cases. Like this is why you never want to whiteboard something like this. Because like what happens if there's like an odd number of entries?
Don't look behind me then. Don't look at, well, it's not a sort, but like don't look at the grossness that's on my whiteboard right now.
Okay, so basically, and then what you can do is you can sort of like keep combining them back up. So first you split them down, you sort each of the pieces, and then you merge them back together. And you sort the merge, and then you can sort the merge and sort the merge and sort the merge, and then you can bring those up to the next level. And basically, if you just kind of like go back up and keep sorting the pieces, you'll eventually end up with one sorted algorithm. This is really nice because it's n log n guaranteed. Now, it's also a hot mess in memory. So recursion usually is. It depends, like, how big your stack is, what your stack. Anyway, so far afield. Moral of the story, one way we can compare these things is to know about their big O notation, which we're hand-waving a little bit in this class, but there's no excuse to be using an n-squared algorithm generally, unless it's the worst case, and I'll give you a buy on Quicksort. But never implement Quicksort. And why should you never implement Quicksort? Because guess what's built into the C library?
Not Quicksort.
This wonderful function that we're going to use right now.
Oh, you mean like don't build it yourself?
Don't build it yourself because it's literally built right there and it's totally correct. And
oh, yeah.
If we look at the man page for this, which we can pull up the manual page. I guess I'll just do it on a web page. So the Quicksort man page. What section is that? Section 3 of the manual. Man, I'll look on my local. Yep, section 3. So you get this basically, and I'm going to just drop this in the channel so that everyone can do this. you get this basically for free if you just use it. So it is one of those things that we're going to just use it. So if we look at these calling parameters, and of course we have all this nonsense stuff going on, but if we look up here at our calling parameters, then I guess, you know what I can do? I don't need to live in this world. I can just show my terminal because it's built in. So if you just look at the Quicksort man page, then you'll see that you need to pull in standard lib. So you got to make sure that that's there. And then this is going to take a couple entries. It's going to say a base. So this is basically your array that you're going to be sorting. It's going to take how many members are there. So that's how big is your array, just like you were, just like you were passing around. Mm-hmm. What is the size of each entry? So it doesn't really care if it's an int or a float or a long or a char or whatever. All you need to do is tell it how big each one is.
Okay.
And then the one messy parameter, which is a function pointer. And I know how much you love function pointers. But you do need to pass in a function pointer because this is exactly what I was talking about before when I said the sorting algorithm itself does not care about your collation. So you get to specify your own function to compare things with this. And the rules of this function are described down below. They basically say, they say here, the comparison function, third paragraph, is basically saying that you have to return less than, equal to, or greater than 0 when the first argument, you're going to be passed 2 arguments. And when the first one's smaller than the second one, you return less than 0. When it's equal, you return 0. And when it's greater than, you return something that's bigger than 0. So that's all your function needs to do. So to get this to work, you just need to build a function that you can pass as a parameter so that we can send it into this thing. And we need to just specify very trivially that, if parameter 1 is less than parameter 2, we return less than 0, and so on and so forth. Okay, so let's write that first. Do you want to use this, or is it good enough that you just saw the manual page?
I think I got it from the manual page.
Okay. So I can tell you that basically whatever your length of implementation of this function pointer is, and I know we probably need a little bit of practice with these, this is a... This is most of your implementation because this is going to be one line. And by the way, I'm accidentally pointing out the Quicksort. Actually, I'm not pointing it out at all because I'm on the different scene. But there's 2 functions here. There's Quicksort and there's Quicksort R. R standing for reentrant. So don't worry about the reentrant version. That gets into threading and other stuff we haven't talked about yet. But the top one is the one that you're going to be worried about. And that basically you just need to pass in what the array of stuff to sort, how big is how many entries are there on the array, how big is each entry, and how do I compare the two. Gotcha. And if I pass those things in on one line, I get back magically a sorted array. It's not returned to me because that would be a stack copy, so we don't want to do that. Instead, it just operates on base directly. So it'll just in place put them into the right order. So like I said, never implement this for real. So in real code, in real actual code, never implement a sorting algorithm. If you need to use Quicksort, you've always got it. If you want some of the other stuff, they're available in libraries. Sometimes they're there, sometimes they're not. Never implement one. Never implement one unless you're just learning how the algorithm works, which is totally fine.
Gotcha.
Okay. Getting off the soapbox. So that is Quicksort. The one other thing that I'm going to mention to you is Knuth. So we've talked about Knuth. I don't know if you've ever seen Knuth. Knuth, the art of computer programming. This is it right here. This is Knuth. This is the book on searching, sorting, hashing, and all these kind of algorithms. It's typically, I think it's 3 or 4 volumes. I don't know how big it is. Oh, he's planned more. Okay, so anyway, Knuth is just referred to as Knuth. This is I don't know, Grey's Anatomy. This is Grey. Knuth is Knuth. So Knuth says this is the right implementation. He used to write it in Mix. I don't know. I haven't seen an updated copy of Knuth. So Mix is this archaic sort of assembly language, but it's really simple to understand, and you can always see like what's happening in terms of like raw memory and stuff like that. Mm-hmm. Okay, so and sorry I missed King Lintine's question earlier. How important is computation structures and computer systems engineering for software engineering? I would say it's very important, but I think the place where most people get tortured with it is whiteboard interviews, which is naughty.
Are we at the drinking portion yet?
We are totally, I think, at the drinking portion. Let me just check the notes.
Okay. Oh, whiteboard interviews just give me that.
Yeah, that's a topic.
Pavlovian response.
We're going to talk about that. Let's see. Okay, so algorithm choices. So we can always trade size, space, whatever. Knuth, we look it up if we have to. We use a library. Because using libraries is better than torturing yourself and implementing these things. I will drop in the chat. There's a really nice comparison of sorting algorithms from the Wikipedia. There's some nice visual things. You can see the sorts like happening visually with sticks, which is kind of cool. And there's some websites. I actually found one which I don't have here, but I had a really nice website that could compare them really visually and very quickly, and it was kind of nice. I'll have to dig it up. Anyway, there is one last thing, which is to say that as fast as you can get with a comparison sort is n log n, but there are non-comparison sorts.
Yes.
So if you're willing to sacrifice insane amounts of memory, you can kind of misuse a hash function. You can use a radix sort, and you could basically just read each entry once and put it into the right spot in memory, and that's it. It's just takes a disgusting amount of memory. So if you don't care, there are faster than n log n.
I mean, it's the trade-off that happens with pretty much, I feel like, everything.
Yep.
Which is speed, memory, like you're going to be sacrificing something. So.
And that's great news, Kim. I'm glad you found the TTL logic to be able to do your EEPROM programmer. Okay, so with that said, do you have any questions?
Nope.
That's